Hey, in this one I wanted to show you std variant in C++, which is from an old standard already, but yeah, I've been using it quite a bit recently, and yeah, it's quite nice. So you have this thing which I've did a video on a while ago called tagged unions, and basically it's a way to have like dynamic typings in C. And so the technique goes as follow. You create a struct, you have a member which is an enum of the type which is represented by the struct, and then you have a union with the potential types. And so the goal of this is that different types can can reuse the same memory, and so you don't you don't duplicate memory or use the unnecessary memory. And the way you use it is you create it, you assign the tag, and then you assign the value, and then every time you use it, you need to check the tag to know what is the actual type represented by this. And so this is very nice, but C++ variants make this process a bit less cumbersome in some situation. So the way you use it is you include the variant header, and then you do std variant, and here you can specify a list of types which will be well, the possible types for your variant. So let's say I want something that can either be an int or a string, and I will call my thing v for variant, and I will say that v is equal to 42. So here the current type of the variant is an integer, and if I want to get it, I need to do int, let's say x, and there is a function for it called stdget, and you can specify the type of the variant, the type of the alternative of the variant which you want to get. So each one of those is an alternative in the, I don't know, glossary of variants, like int is the first alternative and std string is the second alternative. Doesn't really matter, but you do stdget with the type of the alternative, and then you do v, and if I print it, so x is equal to something, x, we can see that x is equal to 42. If I try to get the std string instead, you will see that it... okay, rookie mistake, forgot to put auto. But you can see that if I try to do stdget with std string instead of int, I get an exception, which makes sense, because yeah, if you would do that with a tagged union as before, you would just get garbage data. So it's a bit better to have an exception. And so yeah, next you can, of course, you can change the behavior of your variant. So with std holds alternative, and here you can specify the type, and you specify your variant like so. This returns a boolean if the variant actually contains the alternative. So we can say if it's an x, an int, we get the int inside of it. So else if std holds alternative std string, you specify the variant like so. Like so, and here instead of getting the int, you get the string. And so you can see that this should work. This prints 32, but now if the variant is now equal to the string hello, it will correctly go in this branch and print hello. Yeah, and you can see that checking all the time for holds alternative and get is a bit cumbersome, so there is a bit of a shortcut. There is std get if, which takes a pointer to the variant and will return you a pointer to the element. So here x will be null if it's not an int, and so it will go to the next one, or it should. Oh yeah, since x is a pointer, I need to dereference it, and so if I do the same thing for std string here, I can remove that one again. I can dereference that one, and I think I've made a slight mistake somewhere. unqualified ID before return. Oh, I just forgot a curly. Brace, but here it's the same behavior as before. If I set it to 42, we will see that it will go in this branch. And so yeah, that's pretty much all you have to know about STD variants for them to be useful in your code. You can have as many alternatives as you want, and yeah. So now for a few let's say bonus knowledge. If I don't initialize my variant, so the default constructor of a variant will default construct the first element of it. So here it will be an integer. If instead the first alternative is a string, it will construct an empty string and the type will be a string. So yeah, it went here. And so if you want, and maybe that's not something you want, so there is a thing called std monostate that is kind of like a placeholder for an empty alternative. And so yeah, if you want that by default your variant doesn't contain anything, you should use monostate. And here you will see that well, nothing is printed. We can do else here, like this is monostate, like so. And we can see that now by default it's the monostate thing. And so yeah, that's about it. There is also stuff I saw with exceptions and visit, but those don't seem that useful for a quick tutorial. So yeah, this is all I have for today, and yeah, hope you learned something, and yeah, see you in the next one.